Okay, good afternoon, morning, or evening. Pre-Cal 20, day 5 here. Let me just open my um, notebook here. Okay, so day 5 in geometric sequence. And last day we did a few questions on just the basic formula for geometric sequence. But we didn't do anything other than find the general term. So we're going to do an example of finding T1, finding N, and finding R, which we probably know how to do already today. And then we're going to do a few practice questions from the text. So this is the second day in section 1.3 that we're working here. And what we're going to do is just a few examples. It probably won't be more than 30 minutes today. So let's start off with the first example that we have here, finding an N value. Okay, so let me paste it in here for you. Let's try blue. Okay, so the question that we're going to be dealing with here is an example finding an N value, okay, in a geometric sequence. So maybe I'll put an extra space in here. Okay. Okay, so finding the N value, and this is, of course, if you're not sure, we're in geometric. Yeah, we'll put that, sorry about the yawn there. Put that in brackets. So a food sample has 100 bacteria and they double every 7 hours. Write the first 5 terms of the sequence and find how many or how long it takes to get to 1,638,400 bacteria in the sample. So the first thing that we should do is we should define everything that is given to us in this example. So let me get to a marker here. And we'll use green and we'll make it thin. Okay, and let me get my sheet out here. All right, so the first thing is a food sample is 100 bacteria, and they double every 7 hours. So if it's doubling every 7 hours, we know that R is not 7, it's 2. Doubling. 7 hours is just telling you how long it takes to double. Doesn't matter what that is. It has nothing to do with the math here, other than how long it takes. Okay. We have 100 bacteria originally in the food sample. So the original number that we have of the bacteria is called our first term, which we signify with a T1. Okay, and then we want the last term we know that we're interested in is this 1,638,400. And what they're interested in is the first 5 terms of the sequence. So we got to find T1, which we do have. And then we have R. And we could just write it out. We could go 100 times 2 times 2 times 2, which we could do for the first part. It's probably easy to do that. So our first term is 100. R is 2, so our second term is 200. 100 times 2. Our third term is 200 times 2, 400. Our fourth term is 400 times 2, 800. And our fifth term is 800 times 2, which is 1600. So that is it, and it's going to keep on going until we get to this number here. Now, that's our last term. That's the one we're interested in. So what we need to do is find out how long it takes. So we have to know how many terms it is before we get to 1,638,400. So we have to use, or we have to find the N value. So we know that the general term is equal to the first term times R power of n minus 1. And we have to somehow solve for this. Now, how do you do that? That's the important thing here. Let's make some more space here. Okay, how do you do that? Well, the first thing is, let's just plug this in and then isolate the r to some power on its own. So 1,638,000. Sorry, guys. I don't know why I'm yawning like that. Goes there for Tn, and then 100. R is 2. N minus 1. Okay, now what we have to do is we have to divide each side by 100 first to get, we want to isolate this 2 to the n minus 1. So if we divide by 100, we get 1 0 gets removed here. So it turns out to be 163,840. And that's equal to 2 to the power of n minus 1. Now, since this is pre-Cal 20, we haven't done logs yet, which comes later on. So you don't know how to solve for this mathematically, but you'd have to use logs. So the only way to do this is to do some trial and error. So what we got to do is we've got to find out 2 to what power is going to equal 163,840. So what you do is you take your calculator out, and you're going to be using that power button, which is like that or like this on the calculator. And I'm going to go, well, let's try 2 to the 10th. 2 to the 10th is only 1,200 or 1,024. That's not enough. Let's try 2 to the 12th. 2 to the 12th, that's only 4,000. Well, we got to get up there. Let's try 2 to the 15th. Oh, it's only that 32,000. Okay, so let's try 2 to the 18th. Okay, so we now passed it. So let's try 2 to the 17th. Okay, that's under it. So it's somewhere in between 17th and 18th. I think what I did was I put one too many zeros there in my question. Oh, I know what I did. I made a mistake. For dividing by 100, you got to drop 2 zeros. Let me fix that. So that's going to make it a lot easier. Sorry, guys. It should be this, right? Okay, now we're looking for 16,384. That's going to be a little bit easier. My fault, gentlemen and ladies. I apologize. Just let's reiterate here that my mistake was when I divided by 100 here, this 2 zeros should have dropped. So this should have been no 0 there. Okay, so that when I'm doing the trial and error, I should be trial and erroring a bit of a smaller number. Okay, so let me fix that. All right, so that makes it a little bit better. Oops, I don't like the fat marker. All right, so that's going to be a little easier to do. So we go 2 to the power of, okay, we were on, I guess, probably, let's try 14th. 14 works perfectly. There we go. So 2 to the power of 14 is our 16,384. So that means that 2 to the power of 14 equals this number. So now that means if we're trying to figure this out, so that means we're going to now compare the two exponents, right? So if we say that this is 2 to the power of 14 over here, and it equals 2 to the power of n minus 1, okay, we're just taking this number and writing it as a power and keeping this as a power. So now we can say that 14 is equal to n minus 1. So n has to equal 15. So that means there are 15 terms in the sequence. That doesn't answer the question, though, but it's close. if we know that it's 15 terms in the sequence, how many times is it double? Well, let's do the 5 here. And so it doubles once, twice, 3 times, 4 times. So it doubled 4 times in 5 terms. So in 15 times, it's going to double. It's going to double 14 times. Because that first term is there. Okay, so basically the 14 that we found is what we're looking for. So if it's going to double 14 times, it's going to be 7 hours to double times 14 doubles. And that's going to give us 7 times 14. That's going to give us 96. No, 98, can't read here. 98 hours to double. Up to that question. Okay, I'm going to pause here because you probably heard my phone go off a couple times there. So I'll be right back with you with another example here right away. Okay, so let's just summarizing that one. That was finding an n value so that we knew how many doubles there were. And then when we got how many doubles were where we answered the question. Okay, the second one that we're going to do is finding, we already did finding an n value. So maybe like finding a T1 value or something like that. So let me get into my little bank of questions here. Finding a T1 and an R. Okay, and this one is going to be a harder one. It's going to be that where we have 2 variables missing. Okay, so and this is the other kind of question that shows up. So I'll do this on the next page. So this one is going to be an example 2. This is going to be finding T1, which is subscripted, and R given 2 terms in the sequence. Okay, so this is that simultaneous solving of 2 unknowns, 2 equations. Okay, and this is about the hardest one. So I've got one here that I made up already. So let's just cut and paste it in. Or copy and paste it in this case. And we'll use that blue again. This one we probably isn't that difficult. So in a geometric sequence, the 5th term is 1050 and the 8th term is 131,250. Okay, so let's write down what we know first. So we know that the 5th term, that's T5, equals 1050. T8 is 131,250. So what we have to do is we have to write the general terms for the T5 and the T8. So let's do T5 first. So again, if you're remembering that Tn equals T1 times Rn minus 1. So let's go ahead and do T5 first of all. So T5 is going to be 1050 equals, okay, now T1 we don't know, so we just put it. R we don't know. And N we know is 5. So 5 minus 1 is 4. So there is our first equation with 2 unknowns, T1 and R. Let's do the same with T8. So T8 is this number, 131,250. And that's going to equal T1, which we don't know, R, which we don't know, and N minus 1, so 8 minus 1, which is 7. Okay, so now we have 2 equations with 2 unknowns. Now, geometric, these are multiplied together. So we can't add or subtract them because they have different powers of r, but we can divide them. So we're going to take equation number A, and we're going to divide it by equation number B to get rid of the T1, because T1 divided by T1 is 1. So we're going to take A and divide by B for equations. Okay, so equation A is this. And we're going to divide out this. Okay, now everything is multiplied. Okay, so we got to do this one first. 131,250 divided by, what was that one? 1050. So I get 125. Now T1 divided by T1, they cancel. R to the 7th divided by R to the 3rd, R to the 4th, not 3rd. Right, that's 4 there. That's 7 R's on top and 4 R's on the bottom, so there'd be 3 R's left if we canceled 1 R at a time. So that's R to the 3rd. Exponent rules. 7 minus 4. So now we have to do is take the cube root of 125 to get R. So if I take the cube root of that, which I have to use my calculator. So, oops, I put multiply, not cube root. Five times 5 times 5. Probably didn't even need a calculator for that. I should have known. Okay, so R is 5. Okay, that doesn't give us T1. Gives us R. So we've got one of it. To get T1, we have to go back to either this equation or this equation and solve for T1. So let's go ahead and do that using this here equation. So we're going to solve for T1. Okay, so 1050 equals T1 5 to the power of 4. 5 to the power of 4, if we do that, is 625. Now we divide 625. Sorry, guys. I don't know why I'm yawning. 1050 divided by 625. It's not going to work out evenly because I just made this one up. I get 1.68. And there we have an example of finding T1 and also finding R, common ratio. Okay, I do have some practice here. Let me just check the time. Okay, so that's been about almost 20 minutes. I'm going to pause and double check to see if there's another one we can do here. I'll be right back with you. Okay, last example, finding a general term basically, and some other things. So a bomb bounces as it dropped from 5.4 meters. After each bounce, the height is only 65% of the last height. So first thing we want to do is find R and T1. And then we're going to write the first 5 terms, then we're going to get the general statement, and then we're going to find out how many bounces it'll take to be before it's about 25 centimeters high or 0.25 meters. So the first thing is, let's write out what we know here by looking at okay, so the first bounce or the first height in the series is 5.4. So we're going to start off at 5.4 meters. Okay, that's the first dropped height, and then it's going to come up 65% of that. So R is 65%, 65 out of 100. Now it is shrinking each bounce, so we don't add 100 to it. It's not growing, so you're not adding. You just leave it. That's 0.65. Okay, so that's our A value right there. Our B value is the first 5 terms. So we need our calculator. We start out with 5.4. Then we multiply by 0.65 each time. So 5.4 times 0.65 gives us 3.25 times 0.65 gives us 2.1125. Okay, times 0.65, 1.37, and I'm going to just round it off here now, 1.37. There's more decimals, but we'll just round it. But don't take those decimals off your calculator when you're multiplying. Just round it after. And our last one times 0.65 for the first 5 is 0.893 or so. So there's our first 5 terms roughly. Write the general term. Now this is what gets everybody. How do you write the general term? So you're just finding Tn equals T1 Rn minus 1. So all you do is leave n blank and leave Tn blank. So the first term is 5.4, and then R is 0.65 to the power of n minus 1. So that's all you're doing. All you're doing is plugging in T1 and R, basically. And you can't multiply these two numbers, so you can't do any simplifying. That's a general term. Now, using that general term for D to solve, how many bounces will it be when it's 0.25? So we could say, what if Tn is 0.25? Okay, so we plug it into our general term. Okay, so we got to divide out here. 0.25 divided by 5.4. Okay, and it's 0.0462 or 63 equals 0.65 to the power of n minus 1. Well, how many bounces will it be? Well, we want to find out that exponent, so we have to go 0.65 to what power? Okay, we've already did 5 terms, so we could just keep writing it out till we get there, which might actually be simpler, but we can guess it out. So I'm just going to keep doing that. So if I had I'm just going to get her back here. Um, 5.4 times 0.65. Oops. Made an error here when I'm multiplying. I must have multiplied wrong here. Let's go back. Good thing we checked this. Okay, I multiplied these wrong. Sorry, individuals. Hopefully you caught that. So 5.4 times 0.65 is actually 3.51. Okay, sorry about that. Hopefully you caught that when we were doing it. Times another 0.65. That's 2.28. My mistake there. 1.5. Okay, times another 0.65. I guess I must have had the wrong initial one in there. I might add 5 point something else. Okay, and we'll say 3, and then we'll round times 0.65. Okay, and then times 0.65. Okay, and then times 0.65. I'm just rounding off to the nearest decimal now, times 0.65. Okay, and times 0.65. That's more than 5, but I'm just writing it out here to help us figure this one out. Okay, so if we count, we want to get down to question number D here. We want to get down. So this looks like it's going to be approximately the, well, 1, 2, 3, 4, 5, 6, 7, 8. About the 8th term is very close to 25 centimeters high, or the 9th term. I'm going to pick the 8th term. So if we say that this n minus 1 equals 8, so that's 1, 2, 3, 4, 5, 6, 7, 8, that term right there. I'm going to say n equals 9. So it's going to be approximately 8 bounces, because the first one isn't a bounce, right? To reach, well, we got 26 centimeters, which is about 25 centimeters high. You could even go to the next one and be okay, depending on how you're going to answer it. Okay, so sorry about messing up that when I multiplied that out. Let's just double check one more time. 5.4 times 0.65, 3.51, yes. So be careful with that one. There was an error there, but we caught it before the end of the video for lucky us. Okay, so that's been about 27 minutes. That's long enough. So for practice, we will go with on page 40, page 38, 9, 40, 41, do number 5, BD, the second part there. 6, you can do ACE. Try 9, try 10, and if you feel ambitious, try 14. Okay, so that you can practice those few there, and if you have any questions, feel free to get a hold of me. See ya. Next day we'll be looking at geometric series.